who is an engineer working in the steel industry, but his spare time activity is astronomy, and in particular chasing eclipses and visiting astronomical sites around the world, which is a good way of using up your pocket money, if nothing else, and well done. He's talking about Henry Beighton. Now, Henry Beighton is an interesting character that some of us dealing with beasts downstairs, like the early steam engine situation, know his name for that, but are mildly aware that he had other activities, but not the sort of level that I think Mike is going to tell us about this evening. And he was obviously a guy who moved in circles doing all sorts of interesting things. So we look forward to hearing about that and maybe to get a bit of discussion going. One of the things I like with the discussions that can happen is where we've got one or two people out there who've also delved into a subject, and we can sit back and watch your conversation with them. Excellent. Which can be very illuminating and very useful. But Beighton was mixing it with Newton and Halley and various others on an astronomical front, but also had interests in other areas, and in particular the 18th century development in mathematics, which sounds quite interesting in itself. So I'll ask you to speak to us, and we'll see how we go.
Thank you very much.
Thank you.
Good evening, everybody. Can you all hear me? Are we good online? Well, hello to everybody out there in the world. What? Is that okay? So, as you said in the introduction, I am an astronomer. Let's say I'm an observational astronomer. I do go out. I was looking at Mercury and Venus the other day after the sunset. It's very beautiful at the moment, that parade of planets. But I'm primarily, my keenest interest is in the history of a wonderful subject. And I'm guessing the audience here will understand that the history of a subject, the tapestry across Britain is so rich. I think that's true for industry and engineering, and it's certainly true for astronomy. Sometimes I feel I'm discovering local astronomers faster than I can research them, and it's probably the same fit for you guys. So I concentrate on astronomers from my part of the world. I live in Rugby, where I work for GE Vernova, originally GEC Electrical Projects 40 years ago, but that's my day job, and then in the evenings I research people who've done astronomy in the vicinity of Rugby and Coventry. For example, if you go to Sheep Street, which is one of the main shopping arcades in shopping streets in Rugby, and you look in the right place, you'll see a plaque to a guy called Norman Lockyer, who's an astronomer in the Victorian era in the 19th century. He was renowned as a solar astronomer. He projected the sun through a spectroscope, and so you could look at the lines, and he had an observatory on what's now the site of Imperial College in London. And he compared that with a laboratory next door where they'd burned various substances and checked to see whether or not the lines you could see in the spectrum matched up with lines that you could see in the laboratory. And there was one particular line, an orangey type line, that they couldn't recreate in the laboratory. Norman Lockyer made the bold idea that this was perhaps an element that was not present on the Earth's surface. So he named it after the sun, Helios. He called it helium. He was the guy. Helium is pretty rare on Earth, only found in party balloons. But in the rest of the universe, it's extremely common. So 1 in every 10 atoms in the entire universe was given its name by a guy born in Sheep Street in Rugby, which is not bad. He spent much of his life in London, and then he fell out with the establishment. He's quite a grumpy character, and ended up building his own observatory down in Sidmouth in Devon. You may have gone there. I'll have the pleasure of speaking there in a few weeks' time at the Norman Lockyer Observatory. But he never neglected his roots, and he used to come back to Rugby to meet up with people and to observe with his friend George Seabrook at Rugby School's Observatory. So I look after research his life in the Midlands. There are other people down in Devon who research the rest of his life, but I look after the Warwickshire side. And so I wanted to go to the Warwickshire County Archives, where I knew they had a letter from him. And again, those of you who do research will probably have been to Priory Park, just outside Warwick, a wonderful place full of all sorts of fascinating things. So I went there to see the letter. And when I got the letter delivered to me at my reading desk, I discovered that it was an apology for not being able to make it to an event. So it was not tremendously exciting. Plus, his handwriting was terrible, so it took me about 15 minutes to decipher the fact that it was an apology for not being able to attend an event. So I could have gone off in a huff and said I was wasted, but what I did instead was go to the card cabinet. I think you can see how long ago that was. Open it up and look up A for astronomy. And there were 3 entries. There was one letter, the Lockyer letter that I'd already seen. There was an account, a short but quite interesting account of an eclipse from, I think, the late 17th century, visible from Warwickshire. And then my hairs on the back of my neck stood up when I saw the third item on the list, which was eclipse chart. Because, as you've already said, I am, amongst my many other things, an eclipse chaser. I go around the world to see eclipses of the sun. I have seen 15 of the last 20 total solar eclipses since about 1995 was my first one. I was in Texas last year for the one that crossed America. And I've also seen 3 annular eclipses. And if you're not sure what an annular eclipse is, I will tell you shortly when I've got a proper diagram to indicate it to you. So I love doing it. It takes you to extraordinary places which you wouldn't necessarily think of going to, but because there's an eclipse there, you go there, and even if you miss the eclipse, there's still wonderful things to see. So I wait for this chart to be delivered to me, and when it arrives, again, this is it. And in the moment I saw it, the sun's eclipse, February 18th, 1736 to 37, delineated for Coventry, my nearest town. I'm a member of the Coventry Astronomical Society. I knew correctly that there would be several papers and a talk resulting from this very piece of paper. And to this day, I've got a copy of it up on my wall. To this very day, I still love it. The things I like about it is that it's clearly it's a working diagram. You can see down in the bottom right-hand corner, it kind of breaks out of the margins, so it's not gone through proper design and so on. But it's been done with care. It's been done with love, and it tells an awful amount of information. So this is a mathematician and an astronomer doing mathematics and astronomy in front of me on this piece of paper, and I love it all the more for that. So I'm going to spend a little bit of time taking you through all the things that are on there. Let's start with the date. February the 18th, 1736 to 37. Did he not know what year the eclipse was? Well, of course he did. It's the way that they talked about years at this time, is that the year began on March the 25th, the quarter day, and it ended March the 25th the next year. So say February the 18th, 1736 to 37 is what we would now call February the 18th, 1737, before the next quarter day. Except that, of course, it was before 1752, when they switched from the Gregorian to the Julian calendar. We lost the 11 days. Allegedly, people rioted, though I don't think they actually did, trying to get back in touch with the continent. And so some books, people who build up tables of eclipses and so on, don't like that 11-day jump. So quite a few references will say that it was on the 1st of March, 1737. The people who were there didn't think it was then, but it's more convenient to put it like that. Okay, and as I say, this is definitely for Coventry. So the next thing to look at is on here, and you can see there's 2 things on there, two circles, and the yellow one, not surprisingly, is the sun. So that's a sun-centered view of what's going on, and then the brown one is the moon. And so both sun and moon are moving across the sky, of course, but centered on that area, the moon gradually overtakes the sun, comes up from this area here and goes across there, as both of them are sinking because there's an afternoon eclipse. And indeed, down here, the appearance at different times during the eclipse, you see the moon poke itself onto the solar disk and then move further and further over. And you can see it never completely covers the sun. And there are a couple of reasons for that. Number one is it's slightly off to one side. So you're not in the best possible location to see this eclipse. You might imagine that if you were further away in some direction or other, you'd get a better view where the moon was more central. And indeed, that was the case. If you went up further north in England, up into Northumberland, or best of all, in lowland Scotland, that was the best place to see it from. The second thing you can see there is that the moon is smaller in apparent size than the sun. And the reason for that is primarily that the moon's orbit around the Earth is elliptical. It's not a perfect circle. So when it's furthest away from the Earth, its apparent size is a little bit smaller than when it's at its nearest. And so the moon is probably around about its furthest from the Earth for this particular eclipse, and so it never covers the sun completely. And the best you can come up with is a ring of sunlight around the moon, and the Latin for ring is annulus, so this is an annular eclipse. The moon doesn't cover the sun completely, and you get a ring of light. And that sounds fun, and it is, but it is nowhere near as good as a total eclipse. The reason for that being that the sun is the photosphere, the visible surface of the sun is so overwhelmingly bright that even when 95, 99, 99.5% is covered, it's still too bright for you to look at, and still dangerous for you to look at with any sort of magnification. So if Henry Beighton or whoever was watching this eclipse, they'd have to do it either through some sort of filter or project it so that they could observe it safely. There was no time during this eclipse when it was safe to look at with the naked eye with any sort of magnification. Okay, so the next thing is the detail up here. That's to do with the amount of the sun that is covered. So he's made calculations as to how far across this is, and this is 10.5 digits. Now, I always thought digits, there were 10 of them because I got 10 fingers and 10 toes, but it quite surprises me that I think he's talking about 10.5 out of 12. Digits is a sort of 18th century version of this, I guess, but as in pennies in the shilling, something like that. So 10.5 out of 12 of the sun across here were covered by the moon. So it was pretty deep, partial. A lot of the sun was covered. And then it's talking about estimates of when the beginning of the eclipse was. It was 2:25 in the afternoon. The middle, its best, was at 3:40, and the end was at 5 o'clock. And this is February, so it's getting closest to sunset when the eclipse finishes. And these are local times. There was no Greenwich Mean Time at the time. Okay, and then he tells where he gets these from. This is from Coventry, by the Carolinian tables. These were some tables of planetary and lunar positions and solar positions compiled by a guy called Thomas Street, using the model of the moon's orbit around the sun compiled by Isaac Newton in the Principia Mathematica. So it was cutting-edge tables to do these calculations. So we're down here. I can't even see that, but no, it doesn't matter too much. Then there's the appearance at the various times in the eclipse, and then what are we going to say from here? Let's add some more into here. Top left, the moon crossing the sun, not central from Coventry, which means to say the moon doesn't go completely over the sun. It's deep partial annular elsewhere. 10.5 out of 12 covered by the moon, afternoon eclipse. I've told you all these things. Finally, down the bottom here is the date that it was drawn, which was in July 1736. So this was a prediction of what was going to happen February the next year, rather than a record of what did happen. And finally, we have the name of the guy who drew the chart, Henry Beighton. There's his signature. And we also probably know who it was for because it's in the papers of Roger Newdigate, Sir Roger Newdigate. Now, as I say, this audience, above all others, will certainly know the name of Henry Beighton because he was very involved in Newcomen steam engines, as we will find out later. You may also know the name of Sir Roger Newdigate, but I will tell you a little bit more about the family. This was him, handsome young chap, isn't he? Born in 1720, so he would have been about 17 when the eclipse happened, and he lived in Arbury Hall, which is to the southwest of Nuneaton. Excuse me. And they're a very wealthy family. If you've ever been to Arbury Hall, it's pretty impressive. They originally came from Uxbridge in Middlesex, where they owned Harefield House. And they got their money through being lawyers. The first baronet, Roger Newdigate, bought Arbury Hall, and they relocated themselves, that branch of the family relocated themselves to Warwickshire. And you can tell you're wealthy when the third baronet, if you get Sir Christopher Wren in to build your stable block, that suggests to me that they've got a bit of money. I mean, most of his time, of course, he spent in London redesigning the city, but he did one or two commissions outside. One of the two of the Cambridge colleges were Christopher Wren, including my own. But he also did the stable block at Arbury Hall. And then Richard Newdigate died in 1727. Roger Newdigate's eldest son died his eldest son died in 1734. So Roger Newdigate became the baronet at that time. Now, this was an exciting time, as you will no doubt know, because around about this time, at the beginning of the 18th century, they discovered that Arbury Hall was on top of the Warwickshire coalfields. So not only did they have vast amounts of grounds, but underneath those grounds were solid black gold, isn't it? Is the analogy that they're going to make a lot of money out of these. And the family, including the Dowager Lady Newdigate, who's here, developed these coalfields. And I'll say a little bit about it when I get to Henry Beighton, but it is an interesting story of how industry developed in this part of the world. And the family's still extant. They had to go sideways. Roger Newdigate never had any children, but the family continues onwards. And the current baronet is Viscount Daventry, and I'm very grateful to him for allowing me permission to show this chart of the eclipse. I've requested several times from him. He's still talking to me, but I think he wonders what on earth I'm doing with this chart. So normally, if we were giving this sort of talk, we'd go on to Potter chains and linkages and J.T. Jessiculier and Stonia Parrot and so on. But I am an astronomer, so I'm going to tell you why Roger Newdigate might have been interested in an eclipse chart at the time. And the reason for that is because first half of the 18th century was a great time for British eclipses, possibly the best 50 years or so in the last 2 millennia. There were two total solar eclipses across the British mainland, indeed across England, within almost 9 years of each other. May the 3rd, 1715, and May the 22nd, 1724. And that was then followed by 3 annular eclipses. The one we're talking about now, March the 1st, 1737, so this is adding on the 11 days. July 25th, 1748, April 1st, 1764. So that is 5 central eclipses in 50 years. And I believe, I'll tell you, that is quite remarkable. That is very, very good for Britain. And to give you some idea of how unlikely it is, 2 total eclipses in 9 years, how many total eclipses do you think across the British mainland in the 300 years subsequently? Linda's not allowed to answer this one because she might know. But we had 2 in 9 years, and then how many more do you think in the next 300 years? And the answer is, hopefully you're all old enough to say that 0 is not going to be the answer. The answer is 2 more. That's all. None at all in the 19th century. And then on the morning of June the 29th, 1927, one went across the top of the north of England. I wrote about it in Sky at Night magazine last year. I come from that part of the world. It was cloudy, it was raining. And then August the 11th, 1999, and I suspect very many people here saw that eclipse in some form or other. I was in Totnes in Devon underneath a cloud. Not one of my more successful eclipses, but I wanted to try and see one from Britain in my lifetime. Yeah, I think quite a few of us will have been in Cornwall or Devon on that occasion. And if you go up to Shetland, they will quite proudly tell you that on June the 30th, 1954, there was a total eclipse that just clipped the top of Unst, the northernmost of the Shetland Islands. And that is very true, but Unst is not in the British mainland or indeed in the Shetland mainland. So there was a total eclipse that went somewhere near Britain, but only 2 have crossed the British mainland since this 2 in 9 years. A little bit more successful with annular eclipses, that we had a bunch of 3 in the 19th century. The last one in 1858, Norman Lockyer, the helium discoverer, said that was the event that set him on the path to being a solar astronomer, was watching that annular eclipse from Crystal Palace. One in 1921, and then May 31st in 2003. Some of you might remember that one. I was up in Shetland for that, underneath a cloud just outside Lerwick. I did see part of the eclipse. I saw the sun rising in eclipse, but didn't see the annular bit of it. So, as you see, they're not all that common. Any given place on the Earth's surface sees an eclipse a total eclipse about once every 340 years. And for reasons that I can tell you about later, if you really want to know, at the moment we're favoured in the Northern Hemisphere. Somewhere in the Northern Hemisphere should see an eclipse once every 243 years on average. You might wonder when these things might happen again. And our next total eclipse is September the 23rd, 2090. I will be 128 years old when this happens. It crosses Cornwall and Devon, so all the hotels are already booked. There's going to be chaos on the roads. They don't know what to do. Civilization will break down, etc., etc., etc. But if you make it to 2090, you might as well stick around another 3 years until July the 23rd, 2093, which is the next annular eclipse to cross Britain. So the drought continues for another 60 or 70 years yet. And you might say, I can't be bothered to travel down to Cornwall or Devon. When's the next one in Birmingham? Well, as I say, in the Northern Hemisphere, you get one every 243 years on average, so you might expect 3 or 4 per millennium. It is not one of Birmingham's better millennia. As far as I can see, there are exactly 2. June the 14th, 2151, and then the biggie, May the 5th, 2600, which crosses pretty much the entirety of the UK. I can't wait for it. It may be a little bit further to the west or the east, depending on how much the Earth's rotation slows down over the next 575 years. That's our best estimate, that it should be total from Birmingham. So we as eclipse chasers, plan ahead. My boss once accused me of taking tactical holiday to go see an eclipse, so I gave him a list of all the eclipses for the next 10,000 years. So they expect me to take holiday. Anyway, so you can see that there was the beginning of the 18th century, there were these eclipses. But most particularly, there were the people around who could interpret them. Isaac Newton, of course, had come up with the definitive theory of gravity that lasted until Einstein came along. But also, this guy, anybody recognize him? Normally crops up in my talk somewhere or other. This is Edmund Halley. There we go. The second astronomer royal. You might know him for a comet. Yeah, predicted the return of Halley's comet. He didn't live to see whether or not his prediction was right, but it was, so they attached his name to it. But he did so much more, just an extraordinary guy. Explored, early in his career, explored the South Atlantic, did astronomy, mapping the skies from St. Helena in the South Atlantic. And one of the things he saw there was the transit of the planet Mercury across the solar disk. And he realized that if you observed this event from wildly differing locations, you could do geometry and translate that distance on the Earth's surface to a distance to Venus, and so you could calculate the size of the solar system. It doesn't work that well for Mercury. It works rather better for Venus, which doesn't transit the sun very often. And when it did next in 1761, all sorts of people, Mason and Dixon, for example, traveled around the world to see this transit of Venus so they could get as many different measurements as possible. And that was all because Edmund Halley had this bright idea. If you see my talk on transit of Venus, I have loads of them and I talk all about it. If you see my talk on rainbows, I will tell you about something gobsmacking, just extraordinary, that Edmund Halley discovered about the rainbow. And then he got drunk with Peter the Great. Probably, allegedly. Peter the Great came to the naval dockyards to see how the West did dockyards early in his career. This is probably Peter the Quite Promising at the time. And the court set themselves up. And the story is that Edmund Halley, was a very convivial chap, got drunk with Peter the Great and pushed him through a hedge in a wheelbarrow. I'm not entirely sure this story is completely accurate. Would Peter the Great really have drunk with Edmund Halley? I don't know. Anyway, he used, Halley, that's to say, not Peter the Great, used Newton's theory of gravity, John Flamsteed's observations of the sun to map the path of eclipses. Finally, they were able to predict that eclipses were going to happen right the way back to ancient Greece. There are various laws, and through the medieval period, they're pretty good at knowing they were likely to happen. But around about the time of Newton and so on, they began to get accurate predictions of what was going to happen in an eclipse. And in 1715, for this first British eclipse, Edmund Halley drew a predictive map. So this is the shadow of the moon, crossing Britain from down in Cornwall all the way across, and you can see that was a great total eclipse from Birmingham. We were pretty much on the centre line. You would have seen a nice long eclipse, and the weather was good in 1715. London it was London's last total eclipse of the sun, and they did also see it, shorter in duration. So this is the shape of the shadow, and these are the places. So the shadow would sweep across, and you would see as it crossed any given location there. And so what Edmund Halley did is he did two maps. One beforehand, when he predicted what was going to happen, and then afterwards, one of the first great citizen science endeavours, he wrote to all the vicars along the edges of the path, all these places here, all these little villages, saying, did you see a total eclipse or a partial eclipse? And he told them what to look for and so on. So from that, he was able to revise the path. I can't remember, it's 5 or 10 miles down or something like that. And from that, increase the accuracy of the motion of the moon. And that was the sort of step in accuracy that were really not matched. The next time that it went to accuracy was 1925, when there was an eclipse over Manhattan, and they stationed people on every intersection. So they got it down to 100 yards or so. That intersection saw the eclipse, this intersection didn't. Something like 35th Street northwards saw it, and southwards they didn't. So this was a famous eclipse map. It wasn't the very first eclipse map, but it was the first famous eclipse map. And you can see it was a good day, and Edmund Halley described the solar corona, which is the beautiful outer atmosphere of the sun you only ever see during a total eclipse. A luminous ring of pale whiteness, or rather pearl colour, beautiful pearly white, a little tinge of the colours of the iris, the rainbow, and concentric with the moon. He's not sure where that corona is. That's something to do with the moon, or something to do with the sun, or something in the Earth's atmosphere. They didn't know at that time. It's the outer atmosphere of the sun. Okay, so this was a very popular map. And he produced another one for 1724. And you see, this one comes down through Ireland, goes through the southwest of England, just misses London, not total from Birmingham. You'd have got a nice, deep, partial eclipse, but believe me, go see the total. And then across Paris and down through France, Switzerland, and into Italy. And 1920, and by this time, other people had got the idea that it could be scientifically useful, but also possibly profitable to produce some sort of pamphlet around the eclipse. So people started producing these things. This is one by a chap called Robert Brown, and you can see he's kind of grasping towards what's the best way of presenting the information. And he doesn't make a great job of it. This bit's a little bit like the Henry Beighton's chart of the eclipse, and this one is trying to give you some idea of what the track looks like and what you'll see at various locations. And it's a little bit confused. He hasn't really figured out what the best way to present the information was. 1724 was not as good. 1724 was a cloudy day, unfortunately. I haven't seen too many accounts of it. This was by William Stukeley, who was Isaac Newton's biographer, Harrowden Hill outside Salisbury. I seem to feel the darkness, as it were, drop upon us like a dark mantle. This doesn't sound too good, does it? During totality, the spectacle presented was beyond all I'd ever seen or could picture to my imagination the most solemn. Well, I hope he saw the eclipse, but I have a feeling what he saw was the sky getting dark behind clouds. Maybe he did, maybe he didn't. So there were these two total eclipses, one really successful in 1715, maybe not so good in 1724, and then these three annular eclipses, so people started producing charts. And this is George Smith. I really like this chart. He's doing his best, but he hasn't really got his projection very good. So it kind of it starts off in the Gulf of Mexico, as they used to call it, and then going down across the Atlantic and making its way over here. So it's an accurate discovery of what it's doing, but it's a little bit wobbly on the way. And then he tries to say what you might see from various locations around the world. And I give him full marks for trying to come up with a global path. You know, this is an eclipse that starts in dawn in the Tex-Mex border, works its way across here, and then finishes late afternoon. It crosses Coventry, we already knew that, and then sunset over Scandinavia. But what really sold, of course, was what was going to happen in your area. So I think the more successful charts were one like these. John Haynes saying what happened across Britain. And he says this, so this is the track of annularity. These are the places that see an annular eclipse, and Coventry's down here. So it's some way from the annular eclipse, but you're going to see a deep partial, as Henry Beighton demonstrated. This one's really rather better. I think it's got rather more, you can see it's a little bit further to the north of the Haynes one, and I trust this one rather more. They've got all sorts of diagrams as to what's happening on these various locations. And you might know this name as well, Thomas Wright, another polymath. It was 300th anniversary of his birth about 14 years or so ago, which was celebrated by both the Royal Astronomical Society and the Royal Landscape Gardeners Association, something like that. He had all sorts of interests, but the two main ones were sort of doing a capability brown type landscape gardening, and then astronomical musings, philosophical musings. It's to Thomas Wright that we owe the idea of an island universe, a galaxy. He was the first person to propose it. And he also knew Henry Beighton. He was based in Washington, up in County Durham, where Beighton built one of his Newcomen engines. So Thomas Wright had a pretty good go at doing this. So you can see, there's all these charts around, and I quite like this one. This is sort of lap of honour, saying this is the path of all 5 of these eclipses, 2 total, 3 annular, that cross Britain. So in this context, you can see that a lot of people were drawing charts to predict these eclipses because everybody knew about them because of these 2 total eclipses to start off with, and there was a lot of interest. And there's also that sense, I think, of they could do it because they could, because Isaac Newton had done all the mathematics and they'd understood it, and Halley and Flamsteed had done the observations, that there's certain pride that you were able to make these sorts of predictions. And I'm kind of guessing this is maybe what Henry Beighton wanted to do. If we look at this chart again in black and white this time around, I should really put the colour one in. I got my friend Sheridan Williams, who's written a splendid book called UK Eclipses from the Year 1. All of them. There we go. That's his. I didn't show him this chart beforehand. This was what he thought it was going to be. 1st of March 1737 from Coventry, and you can see that's pretty close to Henry Beighton's prediction. So Beighton's chart was pretty accurate. So we should go on to those. As I say, this may be something that other parts of the audience already know a lot about, but Henry Beighton was a quite remarkable chap. Born 1687 at Chilvers Coton, which was very near Arbury Hall, from a family of yeoman farmers, smallholders essentially, enough to make a living, not enough to get very wealthy. And almost his first achievement, well, the engineering got going as well, but 1713, he became editor of something called The Lady's Diary, which was a yearly almanac, which would have been edited for its first few years of its run by John Tipper, a Coventry schoolmaster, and Henry Beighton took it over and developed it into a very popular journal. At the same time, he was developing the mines in the Nuneaton coalfields, and he became business partners with a chap called Stonier Parrott. Again, I think probably well known to many of you, an entrepreneur who actually put up the finance to actually build these Newcomen steam engines. And his story is quite entertaining. That he and his father, Richard Parrott, were building these things all around the Midlands, and then they had a collaborator, George Sparrow, and they fell out, and there was a sort of battle to the end, which George Sparrow won. So in the end, Stony Parrott went bankrupt, but that's towards the end of his life. So he actually, the Parrotts and George Sparrow were the people who put up the finances and actually put the thing together. The Newdigates wanted Newcomb engines to pump the water out of their mines, and all this needed an engineer in the middle to make it all work, and that engineer was Henry Beighton. And Henry Beighton worked on the Nuneaton coalfields, and then he went up to County Durham, to Washington, to installing a steam engine in Washington, which was where he met Thomas Wright. And doing these things, he made various improvements to the Newcomb and Steve engine. I mean, Newcomb had worked from Savary, wasn't it? Built the first steam engine. Newcomb and built one that worked. Henry Beighton improved it. And he was invited along to the Royal Society by Reverend de Ségulier, who understood more the sort of from the sort of theoretical side, but he was invited to tell the Royal Society about these improvements that he had made to the steam engine. So he was elected to the Royal Society. And then one of his other interests, he was a surveyor, and he surveyed Warwickshire between 1722 and 25. In the Lady's Diary, there's a sort of annual advert for this map of Warwickshire, and it goes on for several years before he actually started surveying. I think it's like the same way that Clive Sinclair finances computers: get the money in first, use the money to build them, and then sell them. Same thing with the map of Warwickshire. Business confidant of Lord and Lady Newdigate, and then he wrote various astronomical texts: use of the moon's instrument, use of the quadrant. I suspect use of the moon's instrument was probably navigating by checking the position of the moon in the sky. You can use it to try and figure out the longitude. Not easy, but it was a possible solution to the longitude problem. So let's look at these things in a bit more detail. This was the Lady's Diary. There are various complete runs in libraries around the country. It went on for more than a century or so. And you can see it's containing many delightful and entertaining particulars, peculiarly adapted for the use and diversion of the fair sex. At least the marketing on it was that it was for women, a journal especially for women. Though if you look at the people who are contributing to it, it tends to be more men than women. But you've got to give them full marks for actually trying to market this to women. And of course, there's a portrait of the Queen, if you're wondering who the lady was, George II's bride, I guess. And the mathematic content in there was pretty good. Every year, people would write in with various questions and queries, and then people write in the next year with the solutions to them. So there were various puzzles and then inquiries as to mathematical questions and so on. The theory of elliptical functions, which I ought to know, having done maths, arose out of a series of papers by John Landon in this journal. In the next century along, Ada Lovelace, Lord Byron's daughter, wrote a commentary on the use of Babbage's calculating difference engine, which a lot of people would regard as being the first computer algorithm. She wrote it, and it was in the Lady's Diary. A theorem of Napoleon, allegedly of Napoleon, was actually first published in the Lady's Diary. So it was a serious mathematical journal and one aimed at the fairer sex. I mean, there were all sorts of other journals around, so I think that they're trying to make this the unique selling point. It's for a journal for the women. Okay, and I'm sure this diagram may not be completely unfamiliar to you. I've been reading various things around it, and this one I think is the Washington steam engine, County Durham. There's another one which claims to be the Griff steam engine, although it's claiming one is a mirror image of the other. But these linkages here are of tremendous importance to the industrial archaeological community, is to figure out what Beighton did, what he did to improve the going of the steam engine. And say this was found in Worcester College in Oxford. They're not quite sure how it got there. Probably came via the Royal Society. So you guys probably know more about this than I do, but I find it fascinating. But you say, in my case, it's one of the many bows to Henry, one of the many strings to Henry Beighton's bow. Then there was the map of Warwickshire. So here we are. This is a little bit round where I come from. Coventry's up here, Rugby's just off the right-hand corner here. And Coventry has expanded somewhat in size. And you can tell the same thing if we go to Birmingham. There we go. There's Birmingham. A nice little duck pond at Winson Green over there. Yardley and Sheldon, which are out in the sticks, were literally country parishes a long way outside the city centre. You can see, Birmingham kind of expanded in the 19th century, didn't it, as the industry came in. But you can see how much the city has expanded. And I gave this talk to Birmingham University a few years ago, which is down here, Edgbaston, the little village down here. And we wondered whether or not the university was actually in the old Warwickshire or the old Worcester. And in the end, we decided it was probably this side of the stream, just inside Warwickshire, rather than this side, just inside Worcestershire. And of course, these days, Birmingham is just huge. Almost all of that is Birmingham, one way or another. And so that's Henry Beighton, an extraordinary man who did extraordinary things. His biographer, Alan Cook, I was wondering if he might be known to you, called him the universal Hanoverian man. He knew so much. It was still possible to be expert in many fields, and Henry Beighton certainly came into that category. Pretty much self-taught. I don't think he was at university or anything like that, but he was a qualified surveyor, he was an engineer, he was a mathematician, meteorologist, and so many different things that he was so good at. You're kind of proud of him. He's one of these people who made the Industrial Revolution happen. So let's go back to Roger Newdigate now, and so they're sat on the coalfields of Warwickshire in Nuneaton and to the south through Griff and Chilvers Coton. But Roger Newdigate himself, he was in 1720, born in 1720, so 1737. He was just about coming of age. So as you did if you were in the aristocracy, he went on a grand tour of Europe. And then he was a student at Oxford University, and then eventually became the Tory MP for Middlesex back in the family's other part of the world. And he married this beautiful young woman, Sophia Conyers, in 1743. Must have been a handsome couple, I think. I was going to say it didn't last that long, so probably 30 years or so. So I think she predeceased him because he remarried a lady called Hester Munday in 1776, and he had no children. But he and Hester Munday adopted a daughter called Sally Shilton, a young girl who had a beautiful singing voice. And they heard this girl singing, made inquiries as to who she was. Turned out she was an orphan, and she got on so well with them, in the end, they adopted her. And Roger Newdigate was Lord of the Manor at Arbury. He ascended to it very early on, but he was Lord of the Manor for 72 years and became increasingly reluctant to leave Arbury. I wonder how much of that time he was increasingly reluctant to leave Arbury. He was still Tory MP for Middlesex. I don't know. But anyway, this is a description of him, as fine a specimen of the old English gentleman as could well have been found in these venerable days of cocked hats and pigtails. Who do you think might have written that? Who came from Nuneaton? George Eliot. Her first... before she started writing Mill on the Floss and so on, her first published work was a series of stories called Scenes from Clerical Life, which were stories built around stories she'd heard as she was growing up in Warwickshire. And one of them was the tale of the young girl who was adopted by the Lord of the Manor. And it's called Mr. Gilfil's Love Story. And so it's second-hand because Newdigate was long dead by the time George Eliot came along. But this was her view of the Lord of the Manor at Arbury. So it's quite nice to have George Eliot write nice things about you, isn't it? It's very good. Just one more slide about Arbury Hall. Roger Newdigate rebuilt Arbury Hall to call it the Gothic gem of the Midlands. And I would certainly encourage you to go there if you haven't been there. Check beforehand. It's not open very often. They've got a website when they tell you what days it's open, but it is beautiful grounds and it's quite exquisite decorations inside. Really lovely house to go and wander around. Of course, I'd be interested in the industrial history, and I'm interested in the architecture and everything else. But what I really want to know is, did Roger Newdigate see the eclipse? I kind of had a couple of lucky breaks on here. Number one is I'd spotted in the Warwickshire County archives, going back to their catalogues, that Roger Newdigate had left a diary. So I thought, well, I'll go back and have a look at that, and he'll give this great long description of the eclipse that he saw. February the 18th, 1737. Unfortunately, it turned out to be more got to go to the dentist a week on Tuesday type diary. This is the entirety of the entries for the end of 1736 and the beginning of 1737, and you can see he put nothing in at all for February 1737. So he can't have been that impressed with it, even if he did see it. And I honestly, this is the point at which it ran out for Roger Newdigate. I have no idea whether or not Roger Newdigate did see this eclipse, or indeed it may just be a coincidence that it's in his papers. It may have been, Henry Beighton might have left it lying around and it got swept away into the Newdigate papers. I don't know. I do notice he was a very student. He went to Warwick races on August the 10th, 1736. But he also talks about Mr. Bradley's lectures a couple of times. I would really like to think that Mr. Bradley was James Bradley, who went on to become the third Astronomer Royal, succeeded Edmund Halley. He's the guy who proved for the first time the absolute proof that the Earth goes around the Sun. The Earth moves with the aberration of starlight. Quite not a very well-known figure, but to us astronomers, quite important. But I have no idea whether or not Roger Newdigate. I would really like that to be James Bradley, but of course it could have been Mr. Bradley, the French lecturer. I don't know. So that's as far as I got with Roger Newdigate. A little bit further with Henry Beighton. I was in correspondence with Alan Cook, who wrote the pamphlet about his biographical pamphlet, and he said, check the lady's diary, which I thought was a pretty good idea. Before that, actually, I realized that Henry Beighton had written meteorological records, and it turned out there were some in the papers of Thomas Wright up in Durham. So quite a few years ago now, I went up to Durham. There's something else going on that weekend, but I spent some time looking at the meteorological records that Beighton had left with Thomas Wright, and there were none for 1737, so that didn't help. But this, for what it's worth, is 1724, when the eclipse was in the middle of this period here, where there's no record of anything happening. So I don't know whether or not Beighton saw the eclipse in 1724. But Alan Cook suggested, well, take a look in the lady's diary, because there was always, in the almanac section of it, as opposed to the mathematical problems section, there was usually something saying what was coming up. The eclipse is calculated for 1717, the eclipse is for 1721, various diagrams saying what they think will happen, and then sometimes, if we're lucky, reports of what happened in the previous year. And we did get lucky in 1738. There was a record of various people who'd seen the eclipse in 1737. For example, this observation from Kettering, to the east of where I am in Rugby, the moon touched the lower spot 3 hours, 18 minutes, and so on. And then Griff in Warwickshire began at 2:25, mid-4:05, ends at 6 minutes past 5. And Griff was where Henry Beighton grew up, with his home. So I'm really, really hoping that report from Griff in Warwickshire was from Henry Beighton, who did see the eclipse that he had predicted. If you remember from the chart, he predicted it would begin at 2:25, so very good. The middle, I think, was a little bit before, 3:50 or something like that, and the end was 5 o'clock on the dot. So he's not perfect with it, but it's not bad. And of course, the midpoint of an eclipse is difficult to calculate. So he's got the beginning spot on, the end only out by a few minutes. So that's pretty good. And he also said what the weather was, because he collected weather records. And he said, on the 15th and the 16th, great rains. On the 17th, stormy. But on the 18th, the day of the eclipse, it was merely windy. So I really, really hope that Henry Beighton saw that eclipse of the sun in February the 18th, 1737. The evidence is pretty good, I think, that he did. So, there were some descriptions from further north where the eclipse was actually annular. Colin Maclaurin, famous mathematician, Maclaurin series and so on, says, observing for Edinburgh, a little before the annulus was complete, a remarkable point, a speck of pale light, appeared near the middle of the part of the moon's circumference that was not yet come upon the disk of the sun. And that is what later got called Bailey's beads, is that as the last bit of the moon is moving across the sun shines through the deepest valleys on the moon only. So you see these beads of light. And it's telling you that the moon's surface is rough. It goes up and down. There are valleys and hills and so on. During the appearance of the annulus, the direct light of the sun was still very considerable. Yep, too bright to look at. Places that were shaded from his light appeared gloomy. I agree. The light silvers, it thins, becomes more wintry. There's a dusk in the atmosphere, especially towards the north and the east. Remember, the shape of the shadow was actually heading northeastwards down to southwestwards, so he's spotted. It's darker towards the northeast. Those chambers which are not like their lights westwards, obscurity was considerable. Venus appeared plainly, quite often see the brighter planets during an eclipse, and continued visible long after the annulus was dissolved. And I'm told that other stars were seen by some. Yeah, maybe not. Venus, certainly. You can see Venus in the middle of the day if you know where to look. But when there's an eclipse, you quite often see Venus pop in a few minutes before totality or annularity. So I would agree. So what did it look like to him? Well, I can't tell you because I wasn't there. But I was around for the last annular eclipse that crossed this globe, which was on October the 2nd last year on Easter Island in the South Pacific. And then it crossed Patagonia, but it got the chance to go to Easter Island. The tour company that I do the guest astronomy with, Julie, who runs it, said, "Do you want to go to Easter Island and be guest astronomer?" There is only one answer to that. The answer is yes, I really do want to go. And so Linda was on the same trip, and my group observed from the Rano Kau volcano on the south side of Rapa Nui, Easter Island. Linda had a more comfortable location with a toilet block further inside the island, and they both worked. However, where we were, it was a 5.5 minutes worth of annularity, and the first 30 seconds or so there was a cloud in the way, which normally we would not be too pleased with. But what it did mean was that you could actually see with the naked eye the annular eclipse through the cloud. Do not even dare look at it with binoculars just in case the cloud shifts. Yes, but you could clearly see it with the naked eye. And my great good friend Deecha Madhavan, Deech, took this beautiful photograph of the annular eclipse as seen through cloud. And you can see this sort of meteorological corona. That's not the solar corona, this is effects in the cloud from the sunlight. And then the cloud shifted and Deech took the picture he really wanted to take of the annular eclipse, which was this fantastic image. Yeah, so this black hole here is the moon, and then around it is the annulus, the ring of sunlight, with solar prominences erupting from it and the granularity on the solar surface. Absolutely staggering picture, very, very, very beautiful. I mean, sometimes you can see, if you turn up the volume and so on, you can see details on the moon from Earthlight and so on, but actually that's far closer to what you actually see is a velvet blackness on the moon. So that's the annulus. That's what makes it an annular eclipse, is that ring of sunlight. It was never a perfect annulus because Easter Island was not on the centre line, but that's the only land for 1,000 miles in any direction. So that's the best that we could do. If I've inspired you to go and see an eclipse, and I hope I do, well, there's one in about 24 days' time, visible from Birmingham. There's a partial eclipse, which was visible from England. It's nowhere is it either total or annular. The moon's shadow, as it were, goes over the top of the pole, so the best you can see is a partial eclipse. And so I hope people will put telescopes outside here at the Science Museum. I will be in Paris. There's a historical astronomy conference at the Juvisy Observatory in Paris, where hopefully we will see the eclipse. The next annular eclipse is February the 17th next year, conveniently located in the unpopulated bit of Antarctica, so probably not many people are going to see that. But I would actually commend not the annular eclipses, which are all right, but the 4 total eclipses. August the 12th next year, an eclipse goes down the side, total eclipse goes down the side of Greenland, just clips the Reykjavik of Iceland, and is a sunset eclipse over Spain, concluding on the Balearic Islands. Just to the north of Madrid sees totality, just to the south of Barcelona. EasyJet and Ryanair will get you there. Deech and I are probably going to be guest astronomers on a cruise to Greenland. It'll probably be a war zone by that point, but never mind. But I think most people will go to Spain. If you miss August the 12th next year, well, just under a year later, 12 new moons later, there's another total eclipse that clips the bottom of Spain. Gibraltar sees the total eclipse for that one, and then North Africa, bits of Morocco, bits of Algeria, Tunisia, Libya, but it is a 6 minutes of totality, which, believe me, is a heck of a lot, over Luxor in Egypt, where the chances of cloud are quite slim. 12 new moons later, July 22nd, 2028, another eclipse over quite cloudless territory, pretty much all the way across Australia, from Western Australia downwards through many of the Australian states, leaving Australia over Sydney Harbour. Fantastic place to see an eclipse. Then across the Tasman Sea, concluding in Queenstown, one of my favourite places in the world, and Dunedin on the South Island. And then finally, we have to wait almost over a couple of years for the next and final one of this sequence, total eclipse on November the 25th, 2030, which starts off in Namibia, Botswana, South Africa, all wonderful places, across the southern Indian Ocean, ending up as a sunset eclipse just to the south of Adelaide in Australia. So coming up for the next few years is a wonderful series of eclipses crossing accessible, beautiful parts of the world. So now's your chance. Go and see one. They're beautiful. I was going to bring some eclipse glasses, actually, and I forgot to. Never mind, sorry. If I have inspired you, well, first of all, go see an eclipse. But if you want to read more, I've been involved with a book, came out this time last year, called Eclipse and Revelation, Total Solar Eclipses in Science, History, Literature and the Arts, comma before the and, because it's from Oxford University Press. So it's an Oxford comma. I contributed a couple of chapters. I was asked to by my old friend Tom McLeish from university, a professor of natural philosophy at York University. Unfortunately, Tom fell ill with what turned out to be terminal pancreatic cancer. So in the end, I ended up editing it along with Henrica Langer, professor of Renaissance Italian art and architecture at UC Berkeley in California. After 30 Zoom meetings editing the book, we finally met in real life in Texas for her first eclipse of my 14th. And so I commend it to you. So it's a fun book, really good, worth doing. But if you want to know more about Henry Beighton and so on, these are some of the sources, some of the many and varied sources that I consulted to go through here. I'm told some of these names are not unfamiliar to you. Tom Roltz was chairman of this branch for many years, I think. So, I mean, Mr. Allen and Mr. Cook and so on are probably have come and talked to you at some stage in the proceedings. So it has been absolutely fascinating. It's one of the things I love about researching this sort of thing is the directions it takes you that you were never expecting. You know, I saw an eclipse chart and soon I'm thrown into the 18th century when exciting things were happening in this part of the world. I mean, these were the people who kicked off the Industrial Revolution in Warwickshire. You know, there were the people, the canny, the landowners, some of whom went by the wayside, but some people like the Newdigates understood what was happening and built the mines and got the technology in. And then there were the wide boys, the entrepreneurs, the Stonia Parrots and the George Sparrows, taking risks and sometimes losing their shirt off their back to make it all happen. But in the middle was the technological expertise, was the guy who actually made it happen, Henry Beighton. And what he did, he was good at everything. He was good at meteorology. He was good at surveying. He was good at mathematics. But he was also good at two other things. One is steam engines, and the other one is making eclipse charts. So thank you very much. Running out of voice.
Oh, thank you. That's put it more into context, which is interesting. And begin to realise that there's more to this man than just the steam engine bit, which some of us had been working with for a long time. I think that obviously if there are questions and things, we'll take those. And also, Philip, the arrangements for people online.
Yeah, I was only going to say, for those of you here, wait for me to bring the microphone to you, because then people here can hear very clearly. The recording picks it up, and those at home can hear what you're asking, which otherwise they can't. So wave at me and I'll bring the microphone. And for those at home, if you want to use the chat function on Zoom, then we'll read out any comments or questions that look interesting. So we have a question here.
Thank you. The first chart that you showed, you said it was actually a prediction, not an actual report.
Yeah.
Was it accurate?
Yeah, it was very accurate. It was, as I say, I didn't show it to Sheridan Williams, who calculates these things, and I trust Sheridan's models and so on, and he predicted the same thing for Coventry that Henry Beighton did. So it was very good, and the timings were pretty close to what Henry Beighton actually observed within a few minutes. So I think I commend him. He did a pretty good job. But of course, he was standing on the shoulders of giants, as Isaac Newton might have put it. That he had Newton's theory and the predictions and Thomas Street's tables and so on. So in one sense, he was just sort of turning the wheel, but in another sense, he got it accurate and he knew what he was doing.
Well, thank you very much. Thank you.
We stunned them into silence. You pointed out that the Earth's rotation slows down. Do you know how could you say how much?
Yeah, it's not very much. And what's happening is it's the tidal effect of the moon is slowing down the Earth, and it's fractions, milliseconds per year, something like that. Okay, and what that also means is that the moon is slowly receding from the Earth. And this has sort of entered conventional wisdom, and it is true, the moon recedes on average at 3 centimeters a year from the Earth. What people seem to have got fixated on this. It's also true that the moon's orbit around the Earth is elliptical, and so the distance from the moon to the Earth varies by 10,000 kilometers every month. And it's not really true that then it's 10,000 kilometers away and then it comes to 10,000 minus 3 centimeters, like that. It's a true three-body problem. The sun attracts the moon very strongly, as does the Earth. So the actual orbit is very, very complicated. But they even knew that this moon was receding even before they were able to measure it. They've put reflectors on the moon so you can bounce lasers off it these days and check the predictions where the moon should be. But even 150 years ago, they'd realized that the tidal attraction of the moon was slowing down the Earth, and that ought to cause the moon to recede, and that ought to mean that the tracks of eclipses moved a little bit. So it's actually from historical records, like Edmund Halley's, they were able to figure out that this was true. Yeah. And just extraordinary mathematics that you can predict something that turns out to be 3 centimeters a year in 250,000 kilometers. Just amazing.
Perhaps touched on it there, but how do you surmise back then they went about predicting when the eclipses were going to come?
Yeah, I mean, eclipses are so dramatic that people keep records of them. And not only solar eclipses when the moon moves in front of the sun, but lunar eclipses when the Earth moves between the sun and the moon. So you see them at night. And they spotted things. They spot, in particular, something called a saros. If you have an eclipse, and it's either a solar one or a lunar, it doesn't matter, 18 years and 11 days later, you're quite likely to get another one. And that was known to the ancient Babylonians three millennia ago. They spotted it. Just extraordinary. They knew it better for lunar eclipses because you can see a lunar eclipse over a whole hemisphere of the Earth. Whereas solar eclipses, you might not notice one that's 500 miles away, So, but they realised the same thing were happening. So there are these Saros series, they're called. I think they were named that by Edmund Halley. That eclipses that occur at 18-year, 11-day intervals. And again, this was known to the ancient Babylonians, and most astronomically minded civilizations managed to pick it up. And I remember there was a question, something on the internet saying, is it true that the Mayans actually predicted the solar eclipse of 1991, which crossed Baja California, which sounds the kind of nonsense that you get on the internet. But actually, they probably did. They probably realized that if you go on a series of 18 years from an eclipse, you do enough of them and eventually you get to 1991. So they may not have comprehended what was going on, but they were good enough at pattern recognition to figure out that this sort of thing was going to happen. So, you know, of course, the other thing in those days was astrology. You know, that these eclipses were meant to be portents of horrible things happening, the king dying or the change of government or something like that. So the astronomers, their job was to predict these eclipses were happening, and if you didn't manage to predict an eclipse when one did happen, then, well, it was bad news. You know, the stakes are a little bit less high these days, but you know, so there were people whose jobs depended on good predictions of eclipses, and there were things they could do even 3,000 years ago. And I've seen predictions from the medieval period saying, you know, there's going to be an eclipse this year, this date, this date, this date, this date. They knew these things were happening. May not have been all that accurate, but they had a pretty good idea, even 700 years ago, even when supposedly the Dark Ages. I think we underestimate the Dark Ages, actually, the sort of early medieval period, 11th, 12th centuries. You know, the Islamic culture and so on, they knew a lot. Anything on Zoom?
I think that's the end of the live questions. Is there anything on Zoom? No, no, nothing. So you've answered all our questions.
Well, I'm happy to talk. I mean, as Linda and I could go on for hours about these things. Yes. Yeah, it wasn't Donald Trump. It changed in the First World War, essentially. Yeah, exactly. So, you know, he's not the first time that names of geographical things have been changed for political reasons. You know, the Gulf of Mexico, it's been the Gulf of Mexico for 400 years, come on.
Yes.
Come on. And it's been Denali for even longer. You know, that's the name of Mount so-called McKinley.
A few years ago, wife and I visited her sister in Canada, and we went out around the place, and it's the names of places which were changed at about the First World War, because they were German names, because there were Germans who had come in from Germany as immigrants, and they don't always get it right. So we know it as Keswick, but they all know it as Keswick in Canada. And until you realise the distortion that can happen in pronunciation, but there again, as a Philistine engineer, I've terrible problems with pronunciation of enough for our own words anyway. Well, I think we've, at the moment, virtually ground to a halt, but thank you very much for a very interesting and really quite lively introduction to what's obviously a field that's caught your imagination, and that you've then been able to carry on in more detail. And to come across names that we've met in other contexts is always good, because it broadens your understanding of the people involved and the sorts of things that they got involved with. So thank you very much indeed. I think we should show our appreciation. Sad so far, we haven't managed to feed back the applause from out there, but I will go and check with Dan how many people have been online this time, because we are getting quite a good attendance online. So, right, if I could just do with a few thanks, obviously to our speaker for a very lively presentation and a very good introduction to it. Thanks to Dan with his efforts up top, both directly in shoving things onto the screen and so on, and keeping tabs on the streaming arrangements that are going on. So many thanks, Dan.